Hey everyone. Hello to people watching on YouTube. If you are watching at a later date, this is the R4DS mshiny cohort 4, and today we're going over chapter 16. Let me go ahead and share my screen with everyone. Chapter 16, escaping the graph. This is the end of this section for reactivity. It's a little different, and it took a while for me to wrap my head around the concept of escaping the graph. So for today, our learning objectives, hopefully I'll be able to help explain the main concepts, and we'll get into some examples as well. But we'll learn how to escape the constraints of the reactive graph, the fundamental building blocks that allow Shiny to do just the work that is needed. And at the end of this chapter, you'll be able to understand what are the escaping of a reactive graph constraint and what are the techniques to combine and connect a reactive graph applying manual controls over parts of the graph. I think that's or at least one of the main concepts, is that by escaping the graph, you'll have more control over your app on what it does, but there are some pitfalls to that, as we will, or potential pitfalls, I should say, as we'll see later on in the chapter. And then Matthew, Lucia, please feel free to unmute at any point. This can be conversational, ask questions, or any comments. Feel free to chime in and don't hesitate. So we're going to be addressing the reactive programming, identifying the connections inside the app, and to use reactive val and observe event functions with the scope of applying manual controls over parts of the graph. So we want to figure out what's happening inside the app, excuse me, and how to escape. And just an overview of how we got to this point. Reactive programming is used to specify a graph of dependencies so that when an input changes, all related outputs are automatically updated. The reactive graph describes how inputs and outputs are connected together. It's a powerful tool for understanding how your app works, and it's useful to sketch out the dependencies. So this was an earlier cohort. They showed they built a basic viz of what that looks like, and so that's like the basic approach, is having the connections. Shiny makes it simple as possible, or wants to simplify that process as much as possible. But by escaping the graph, going outside of that, you're going against that the natural order that Shiny, the way that it works. So it does make it a little more complicated, and it can also make your app, I think, less efficient as well. Oh, and then if you do think like these ideas are interesting in this chapter, you might also want to take a look at the Shiny Signals package or the RX Tools package as well. Both are were created to design like higher order reactivity. So definitely check those out if you are interested. Okay, so a reactive graph shows the connections between the reactive components of the app, which are directional, indicating the direction of reactivity. Where the connection is not in use, the graph highlights it in gray color, which means it's invalidated. In this first part, we'll learn how to combine reactive values, which are escaping the graph. And to do this, we need to modify the value of a reactive value, use either reactive val or reactive values for multiple, and then combine them with an observe or an observe event in the server. So we'll see how that works out. If we use the React log library, and especially this React log enable function, we'll actually be able to see how that works out in Shiny as well. It will create the reactive graph for you, and we can explore with each steps as we go through a Shiny app. So our first example kind of walks through this idea. So we have an input, and it's connected. So we have an input and an action button for clear. The reactive function that it connects to says hello input, and then when we update it, it will clear the input when we hit that action button. So they, the past cohort built this reactive graph, but I feel like it's helpful to actually go in and like do it yourself. So hopefully you can see my our studio session. We'll go through this example. Go look at what it's doing. Okay, so it's a basic Shiny app. You type your name in. It'll say, hello, Trevin. So you clear, you can type in another name, then hit clear. And then to view the graph, there's a shortcut. On Mac, it's Command F3. So here we have the layout of our graph with input name up here, input clear down here in our observe event. And we'll just walk through what's going on here. Starts out with an empty string, sure if I mentioned that. Yeah, so it starts out with an empty string. That's the first state. I type my name in. It invalidates it, turns gray. This will cascade through this part of the graph. So our next part is invalidating and the output. Then it'll remove the dependencies. Then the output will start to calculate. It changes color. The dependencies change as well. And it stops calculating. At that point, it's displaying my name. Once I hit the clear button, the input changes. Then it invalidates the observe event, and it kind of goes through the same process here. So that was just the first part of what I did, and then goes back to clear. Excuse me, it goes back to a blank name, and the process is the same for changing the name to Matthew. So for normal or like the usual graph dependencies on what we've been going over, these would be directly connected to one another instead of through the observe event. But since we escaped the graph, so to say, these two are only connected through the observe event and not directly connected. So hopefully that makes sense, or I think it makes sense to me. It's still a little hard to wrap my brain around what's happening. But any questions or comments so far on this first part?
For me, I don't have any comments yet.
Good too. She says all good. Okay. Yeah. So it's a different way to do things. It allows you to be more flexible in what you can do in Shiny instead of just being allowed to have a fully connected app. It does give you more flexibility. So I can go back to the notes. Yeah, so I did say that earlier for running the React and able to get that graph. For Mac users, it's Command F3, and then for other users, it's Control F3. That will open up in another tab. Connecting the right side with the left side. In this section, we combine reactive values and observe events. So figure 16.3. Connecting the right side with the left side with directional arrow to show the missing connection. And so the bulk of the chapter was actually going through case studies to show where you might use this concept in your own apps. So the first one is one output modified by multiple inputs. So I want a text box that's updated by multiple events. So here we have in the code, we have a couple buttons, drink me or eat me, and then it will update with the notice. Starts off by the server, we create a reactive value R where the notice is an empty string, so nothing's displayed. And then it interacts with this observe event. It'll update depending on if you select the drink me button or the eat me button. Depending on which one you hit, it will update. And then it will update the output. So we can take a look what that looks like. So here are just two buttons. You are no longer thirsty. You are no longer hungry. You can take a look at the reactive as well, the reactive graph. So here the app is idle. First I hit the input drink button. It validated the observe event. And then it will go through and update the reactive values. Through, stops calculating, it's idle. And then the same thing with the eat button as well. So the next example was similar, but here instead of just displaying, we're actually starting off with so here the app has an up and a down button. It will increase or decrease the starting value by 1. So here it's a little more complicated. We have starting reactive value n equals 0, and depending on what's selected, that will update that reactive value by adding 1 or subtracting 1. I didn't actually go through this when I was preparing, but it's very similar. So I press the up input button. The observed event for up invalidates. Then it cascades to their reactive values and goes through and there's a similar sequence as well. I did have a question, and I'm not sure if either of you know the answers. I wasn't sure what, maybe I missed this in our previous discussions, but the Steam counter, I wasn't sure what was going on. It says value 0, so I wasn't sure what that was all about.
I think that input is the bootstrap specific theme of the app, because I really think very fast exercise we work with changing that specific value. Yeah, I think it's the same. In the other cases, when we run very basic Shiny apps, like very few inputs and such, still that specific Steam counter input was present. So I do think it's related to Bootstrap.
Okay, thank you, Lucio. Yeah, I was curious what that was anymore. The next two, or the next set of examples, is about accumulating inputs. Here, this example had a text input box of adding names, basically adding names to a list. And that's basically what we have going on here. Our starts off with an empty list or a character with nothing of value. And then when we actually go through and add names into the text input and hit the action button, excuse me, that will update this observe event, and it will update this list of names. The following example is you got a chat. Oh, thank you, Lucio. That's very helpful. So I don't think I'll go through this example on the Shiny, but I think this next one might be helpful. So it's a similar concept, but in addition to the add button, there's now a delete button as well. So similar concept, we start off with a blank list of names for our reactive values. Now, instead of the one observe event, we have two, one for adding, one for deleting. And here's where that where the difference is. This example uses the union and set diff functions to determine whether or not to add or delete a name. I can go over to our studio. Trevin. Show. I'm not sure if I try to add my name again, I think it will just stay the same. Yeah. Yeah, because the way it's written, union, if it's the same, then it's the way it's coded, it will just be a unique set of list of names. If we, so I added my name again. If we delete again, it should delete my name. So a little slightly more complicated. We have our add and delete inputs, our observe events, our reactive. So here we change the value of this. Okay. You change the input add value gets changed, and that cascades to change this input name value. And that changes our reactive value in the list as well. I added the 3 names. It goes through the same process. I added my name again, but the outcome was not changed. And then I deleted, and it goes through a similar process, but with the delete observe event instead. So then the input name gets pointed and depends on the input delete observe event. That's how we take it off. So yeah, there's definitely a lot going on in this graph, and we really didn't add too much compared to like the graph for the apps that we had created previously. So the complexity does grow very quickly. Even just adding or changing your app slightly can increase the complexity quite a bit. But it does help to be able to look at the reactive graph and being able to click through each step of the way. That definitely helps a lot to be able to understand what's going on. What's going on in your app. Any questions or comments before going on to the last example here?
Yeah, one question only to make sure if I am understanding correctly. When you show the reactive graph and there was some lines or edges that they were dashed out, that meant that a change in the value for the reactive value didn't trigger a change into the observer, right? Only the change of the input $@ will input trigger the change, or what was the meaning behind the dashed lines for the reactive values?
Yeah, I think was it this dash line or a different one?
Yes, those two.
Those two.
Are they there because we're using observe event and only caring about the change on input at, or because we're working with reactive values? I didn't get that.
It, it might be related to this observe event where it says after this step, observe event depends on input add, and then after this, that changes to a dash line. So it says it's isolating future dependencies. Is that connected to the arrow means it depends on that input. The dashed arrow still means it depends on that input or that reactive value, and then that input. I think it may be because it's related to that observer event being isolated. Does that make sense?
So if we
I'm
were
trying to
using,
talk myself.
if we were using instead of observe event, just observe, then probably the lines wouldn't be dashed, or
Can you repeat that, please?
if instead of using observe event, we had used something like observe, would that mean that in the reactive graph, the line for input name and the reactive values, those lines would not be dashed? Because now they are dependency, right, of the observer.
Can I change this and run it?
Yeah, maybe like observe, then put rec for input add, and then just the other code.
Try this. You think?
Yeah, but we have to remove the commas and the first curly brace. As like when we do with a reactive expression.
Just observe input add?
No,
like that?
Remove that first curly brace. And leave the code as it is, and maybe put that first input, the input add, and wrap it with the rec function so that it is still a dependency of that observer. No, but without using a comma. I think we would need the curly brace right after the first parenthesis of observe, so we can write
Oh,
multi
here.
lines. Yeah.
Okay. You think this will this should run?
I think so. If not only changing rec for the first input, maybe that will fix it. Maybe try grabbing the inputs with rec. I mean, this function will have been using. And in a new line, maybe I am not sure.
Oh, like this, or
Yes.
all right. Let me go to that graph.
So it seems that it was the case of using observe event.
Yeah, it did change. Let me. Oh, so I didn't see this before, but it says as of Shiny 1.6, we recommend using bind event instead of event reactive and observe event. This is because bind event can be composed with bind cache. Is this the reason it will be executed with an isolate scope?
Yeah, I think so because in the previous graph, when we had some dashed arrows, the only non-dashed arrow for the observe event was the one that we use as a argument before using the code in the curly braces. So in this case, for example, input $@. So that was the only dependency that triggered a change into that observer. The other inputs, or well, the other reactive values or inputs, such as the one from R, the reactive value, or input $name, they only, I mean, they don't trigger a change into the other observe event that we had. They are simply using its values. So maybe that's why they are being connected with the dashed line. So it's not a dependency, it's just calling upon its current value. I know that's how I interpret it.
Matthew, do you have any do you have anything to add?
No, I stepped out a bit and catch up with what was going on. So I just joined not quite long, sorry.
Oh, okay. Cool. Thank you, Lucio. I think that was helpful. I think there's one more example to as part of the case studies, and that was pausing animations. Another common use case is to provide a start and stop button that lets you control some reoccurring event. Here, this example uses a running reactive value to control whether or not the number increments, and invalidate later to ensure that the observer is invalidated every 250 milliseconds when running. So here's our Shiny app code, 2 action buttons, start and stop. And we start off with reactive values, plural. It is set to not run, and the starting value is 0. Then, depending on if we hit start or stop, we'll change the observer event. We'll trigger. Sorry, it will trigger the observer event and then change the value of running, whether or not it will turn on or turn off, depending if it's true or false. And here we have an observe function where if it is running, excuse me, it will update this value of n up here by 1. And that invalidate later is to ensure that the observer is invalidated every 250 milliseconds when running. Oh, and then another one of the dangers that I alluded to earlier of escaping the graph, not only is it an increase in complexity, it can be less efficient, but also, for example, like if you don't have this isolate function here, you can create an infinite loop where it just keeps on going and going. So that's another danger of using like this method. Here we can start it, stop, start again. Here's the graph that we've got going on. So yeah, definitely a lot going on here. Even with such a short app in length. Yeah, I'm curious if I do take this off, and what that will actually look like. Oh, it didn't even run. That's interesting. Yeah. Chat. Nope. Okay, so that was the last example here. But we need to use observe and isolate, otherwise an infinite loop is created. Conclusions from this chapter. They walk through how to create a reactive graph using the React log enable function, or you can change the options to say React log equals true. So yeah, we went through some of that. In addition, the diagrammer package can be of help for you to see the missing piece of a connection in the structure with the rebuilding of the reactive graph manually. Here are some more resources for your perusal. The React log and RX tools libraries, and some more links as well. Here are the meeting videos from the past cohorts. I enjoyed the second one, especially. That was a good overview before presenting on this chapter. And one more parting thought. Once you get the hang of this pattern, it's easy to fall into bad habits. In this simple case, this code doesn't do much extra work compared to the alternative that uses reactive. So there's some drawbacks to that. The key takeaway, or one of the key takeaways of this chapter, things will get progressively worse as the app gets more complicated. Hadley says, having a reactive graph that is as simple as possible is important for both humans and for Shiny. A simple graph is easier for humans to understand, and a simple graph is easier for Shiny to optimize. So using a reactive makes the dependencies between the components very clear. Using reactive values and observers leaves part of the graph disconnected. So yeah, keep it as simple as possible, but if you do need to escape the graph, you can use some of these examples as a guide, as your guide. This concludes the last of the reactive programming used in Shiny. We've learned how it's important, and for the next session, we'll be going through looking at Shiny through the lens of software engineering. And that is, yeah, that's it for this week. That's all I had. I welcome any other questions or comments. If not, I can pass it on to Matthew.
For me, I think I still have to go through that chapter again, because at this point, since we're getting no more comment, thanks for presenting. Lucio, thanks for your contribution. At this point, it's getting more technical, so I think I still have to go through the chapter again and go through this video, because it's just quite an amazing time again, listening to Trevin and getting comments and contribution from Lucio. Let's see what happens next week. We would go through the guideline next week and see what we can do chapter 17 and see if we can merge 18 and 17 and 18 together next week. I'll say thank you guys for this discussion. I look forward to seeing you guys again next week.
Awesome. Thanks, Matthew.
Thank you, Trevin. Nice presentation.
All right, see y'all next week.
Ciao. Bye.